Hello everyone, my name is Bengü Öztürk. I'm attending this Congress from Wageningen University and Research. I'm working in a food informatics group and I'm involved in Big Data Analytics and Management program in Bahçeşehir University. Today I'm going to present you about my study on estimation of body mass index classes of young adults using random forest and decision tree classifier algorithms. As we all know, obesity has become a really big health problem among the individuals in the world, and about 39% of the people in the world have overweight, and also 19% of them are obese people. World Health Organization classified the weight status of people under different categories such as underweight, normal weight, overweight, and obese based on their body mass index. And this index can be calculated using weight and height of the people. Individual attentions, however, doesn't make big impact on population health, so there will be a need of an overarching approach to evaluate the tendency of people to become obese. So there is big data generated by several people through different platforms such as social media, surveys, and hospital test results. So we should get benefit from these data to gain insights into this obesity problem by using machine learning predictive models. And in this study, I used an open source data set that is generated by the researchers in Colombia, Peru, and Mexico that can be accessed through kaggle.com. In this survey, the researchers asked to 2,111 people, young adults, about their eating habits, their physical condition, and also their characteristics, and they collected data based on their answers. So this data set they generated contain information about frequent consumption of high-caloric food, frequency of consumption of vegetables, number of main meals, and consumption of food between meals, and alcohol consumption, physical activity, usage of technical devices, and the way of transportation of these people, and if they are smoking or not, if they have family history with overweight, and their gender, age, and so on. So once we observe the data set, the first 6 levels of the data set, you can see the titles, the parameters on the top column parameters, and these are the answers that are collected and put in a data set. And in this data exploration study, before building the machine learning models, we need to pre-process the data because we cannot use the raw data as they are to be used by machine learning algorithms. So among the 17 variables that will be used to predict the weight status of the people, 2 of them were cleared out, height and weight, because they are highly correlated with the target variable, which is weight status. As I showed you, body mass index, which is the weight status target column, could be calculated by height and weight. So there's no need to put them as the parameters in this data preprocessing. And the age values were converted to integers, and numerical values were converted to categoricals among these features. Here I visualize the parameters, the features, using box plots, and you can see the outlier data in each of the column, and also the distribution of the data in each of the column. And here, generally in this kind of studies, real world data, you may have some outliers, but you don't have to get rid of these outliers because they are the real results of these studies. Here in these diagrams, you can see the weight status distribution among the gender. So how many of the people are female or male in these categories, in obese or in normal weight or in insufficient weight categories. And here you see the frequency table graph of weight status conditions of people, these 2,111 people. So before starting to build these models, classifier models, I split the data set into two sets called train and test split. So 70% of the data set will be used to train the model, and 30% of the data set will be used to predict the classes and to test the accuracy of the machine learning models. Here in these tables you see the distribution of the data within each of the column, within each of the independent variables are imbalanced data. So for example, the number of the people who said yes to family history are really in large amounts than the people who said no. So there is a big imbalance in this data set. Okay, so first of all, I built random forest classifier model using RStudio and RScript language, and I tried different hyperparameters to increase the accuracy of the model. The hyperparameters in this random forest model were number of trees and number of variables tried at each split of the trees. So here I compared different models, different random forest models with different hyperparameters, and I tried to find the optimized one, optimized conditions to have lower error rate. And according to the results, I could get 99% of accuracy by using the optimized hyperparameters in train set, and 80% of accuracy from test data set. So random forest model in the optimized conditions had 80% of train set accuracy and 99% of train set accuracy, 80% from test set. And here again the same classifier model could be also used to find feature importance, to rank the features, the parameters which have effects on the weight status of the people. So it's based on the statistical metric which is called mean decrease Gini, and as this value increased, actually the impact of these parameters are getting increased while calculating the accuracy of the model. The other classifier model that I used and built is decision tree classifier, and I use the default parameters in this model, and I could get like 40% misclassification error rate, and this model had around 60% accuracy in train and 53% of accuracy in test set. Here you can see decision tree plot, and you can see how the decisions are made by this model with 53% of accuracy. So if the gender of the person is female, you go to the right side, and if there are some decision points here, and according to the decision points at the end nodes, final nodes, you could get only one single class of the weight status. In overall performance of the models, we can compare them according to accuracy, precision, recall, and specificity metrics. So these are the metrics that are used to evaluate machine learning models' performance. As I mentioned before, in random forest we could get 99% of accuracy in train data, 80% of accuracy in test data. However, in decision tree model we could get only 60% of accuracy in train data and 53% of accuracy in test data. In the multi-class classification problems in machine learning models, we should also see and observe precision recall results, which also indicate true positive classes. And here, as we see, 80% of precision and 80% of recall could be generated by random forest model, and decision tree model had only 47% of precision and 55% of recall results. Although they have similar specificity values, mostly precision and recall are effective in evaluating model performance in multi-class classification problems. And according to the result of feature importance, we saw that age, frequency of technological device usage, gender, and number of main meals consumed within a day, and also alcohol consumption, frequency of physical activity, and frequency of eating food between the meals are among the most effective parameters that may affect the model performance in predicting the correct classes of weight status. And in overall, as I said, random forest had 80% of accuracy, which means 80% of the data or 80% of the predicted classes are correct classes according to the results. And in conclusions, we compare random forest and decision tree models in predicting the body mass index classes of people. Random forest generates and combines numerous decision trees to reduce overfitting and bias-related errors and produce usable results. And this model chooses features randomly during the training process. Therefore, this can generalize over the data in a better way than decision tree does. And random forests are more resilient than the single decision tree. So if any kind of data is changed in the data set, decision tree models can reveal different results, different directions. But random forests are more robust than decision tree models. And in overall, machine learning models are useful in prediction of health-related risks and help to prevent their occurrence. For example, there are several studies going on the use of machine learning algorithms for sustainable dietary behavior change, and also in personalized nutrition in development of applications. So at the background, there are machine learning algorithms are running. Thank you for listening. Have a good day.